Welcome to another lesson on parabola. So if I come here and I type in parabolas. Okay, so last class we started looking at some of the properties of parabolas, including the focal point location, the directrix location, the length of the lattice rectum, and then we went through comparing it, finding the focal point, comparing methods used in physics where we did the light reflecting off a parabolic shape or a curved mirror, along with another method that we were trying to figure out, we were trying to use because last class I also told you that any line connecting the focal point to the parabola and then back vertically straight down will end up touching the directrix. That left some people confused, so I'm going to try to redo it again today, hopefully with a little bit less confusing. So I've used Desmos here. I've typed in y equals 0.5x squared, gives me a shape. So I'm going to print screen that, and I'm going to try to do it on a Word document. Hopefully that will be a little bit easier to follow. Let's zoom in a little bit. Let's go 130%. Okay, I don't want it that far. Slide this over. Oh, slide this over. Eesh. Go like that. Okay, so now let's print screen this. Oh, Control V. There you go. So now let's crop this down a little bit. If we crop this down, we get, I'm going to try to keep 4 at least. 4, 4, like so. Okay, so now I'm going to take this, I'm going to expand it out bigger, bigger, bigger. Alright, so now I have this line that I magically created before, because I'm going to use that to help us use, to help us place it. Okay, so if I have a random line that I'm creating, let's say I'm creating a random line at the bottom here, um, a random line at the bottom, and we're calling that our directrix. Okay, make it a big heavy weight line, boom, and then make it orange or burnt amber. So from here, if I take this line here and I'm able to replicate it, boom. Now, what the rule tells us is that this line, if I'm vertically shift it and connect it to any point on the parabola, its equal length will be touching the focal point. So this could, obviously this is not going, it can't come in like this because if I do this, I'm past the vertex. So this one has to go the other way. The only way it would make sense is if I go like this, like that, right? This is not a very scientific because I'm rotating it upon using word, try and rotate it. Now, this is telling me that my focal point is up here and my directrix, oh, that doesn't match up at all. It's supposed to be down here. Okay, so let's try differently. If I go like this and then slide this one up to here, what does that give this? Closer. Rotate this up slightly so that it actually touches, and bring that so that it touches there, and this one should be at the end of it, which is there. So now that's pretty darn close. So we have one line here that's at 0.22, and then this one down here is at 0.22 again. So no, sorry, 25, 27, 0.2. Oh no, this is 1. Sorry, this is about half. This is about just over a half, and this is just over a half. Right? So we have our directives to be about a half. Now remember our formula for this shape was, oops, no, y equals 0.5 x squared. Now if I go back to this, from the equation that I given you last time, it said that if you had, make the weighting a little bit bigger, a vertical parabola like this, your equation should be 4cy equals x squared. Okay, now from this, we've discovered that this one has a c value, so from vertex to the focus of about 0.5. Let's say 0.5. We've discovered that this one has a c value. C is equal to 0.5, which means that our whole equation is 4 times 0.5 y equals x squared. So 0.5 times 4 is equal to 2y equals x squared. And then therefore y is equal to 1/2 x squared, which so happens to be y equals 0.5 x squared, like we typed in originally in Desmos. Okay, now this might be slightly confusing because I chose to use 0.5, which happens to be the same measurement that we got from here, 0.5, so bad on my part. So now let's go back here, type in a different one. What if we went 0.25 x squared? Okay, we have a slightly different curve. And then let's screen capture that, do it, paste it onto another page, or paste it onto another page, insert page break, and then paste it here. Same thing as before, crop it so that we just need a small section of it. Boom, boom, enlarge it, slide it down, enlarge it again. Okay, and then let's use our same two green lines. Copy, bring it down here, paste it. There you go. So now we have that there. And we're going to take that line, copy, paste it again, and we're going to slide this on the inside. So if we try to connect this line to this line, doesn't even get because it went too far away, right? So let's move it a little bit closer. That might be too close now. Well, that looks like a good place. It matches up perfectly there. And this one has to be vertical, which means that our directrix should be right across this line right here. 1. Let's cheat a little bit. Let's say, no, too much cheating. There you go. Okay, so it starts at 1, goes out, meets there, comes straight down, and it ends at 1. Right? So right now, in this example, our C has a length of 1. So if I go back to here, so our example 2 now, we again had a different one, and we said that our C length was equal to 1 based on what we just did here. C length was 1. So if I said our C length is 1, if I plug that back in, is equal to x squared. So I plug in 4 times 1 times y is equal to x squared. So that's 4y equals x squared. And I divide that 4 over, y is equal to 0.25x squared, which just so happens to be what we typed in Desmos, 0.25x squared. Okay, so all we're doing is trying to prove that this will give us the equation of a parabola. If you know the distance from the vertex to your focal point as your C, you can figure out the equation of a parabola. I hope this explained a little bit better than what we were trying to look at last class. What we also tried to do last class was we ended up, let's mess up the other picture. We ended up going, oh, if we are able to create a, a line that is a tangent to this, and then reflect a light ray coming into that tangent, it should reflect based on angle of incident, angle of refraction, boom, perfectly off the 90 degrees. Look at that, light ray coming in, angle of incident, angle of reflection, light ray coming out, and it meets at the same focal point. Okay, so that should still work by using the physics way and using the math way in terms of using directrix and everything else. So I hope that explains that section a little bit better than what we tried, or I tried to explain last class. The focus of this class is going to be graphing a parabola given certain pieces of information. So graphing. All right. So when we are graphing a parabola, based on what we are given, there are 3 steps that we want to do. That's way too big. Let's shrink it down to 20. Step number 1 is going to be, if you have it, you are going to plot the vertex and the focal point. That's if you are given both of those pieces of information, you are going to plot them onto your grid. The next thing you're going to do is you are going to plot your lattice rectum points. Now, this you can do if you have the focal point. If you have the focal point at a vertex, you know what the C value is, and you know that that is going to be equal to 4C, right? Like we talked about last class, or the length of 4C. So this is your C, and that is going to be your 4C. And then once you're able to do all 3 of those points there, or all 4 of those points, then you are able to just quickly sketch your graph. Okay, so you only have to follow those 3 steps, and you should be able to draw a graph based on the information that you are given. Okay, so let's try an example. If we had a, let's do that again, but example, we use a red. If we are given this following information, the vertex is 0, 0, and the focal point is 0, -3. Okay, if we are given that 0, 0, 0, -3, can we graph it? Okay, let's follow those 3 steps: step 1, step 2, step 3. So quick sketch again. Here's my y-axis, here's my x-axis, and then pencil in my 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So my focal point, my vertex is there. So I'm going to put my vertex, boom, and then my focal point is 0, -3, right there. Okay, so now I know that if my vertex is here, and this is my focal point, I know that it has to be downwards facing. It's going to be one of these, right? Because the focal point has to be inside my parabola. I also know that the lattice rectum has a length of 4C going across my focal point. So C is going to be 1, 2, 3. So this is my C. This is my C. So it has a length of 3. Therefore, I'm going 4C across. So I need to go 6 this way and 6 that way. Of course, I stopped at 5. I should have kept going. There's my 6. There's my 6. So now I know that my dot is going to be over here and over here on the same line as my focal point. Now, once I'm able to plot those two dots, this is my parabola. That's a terrible looking parabola, but you get the point. Starting my vertex, go straight out, or go curving across my lattice rectum point, and down across there. Okay, we'll do one more example. We'll do one more example of graphing it. So for this example, we are given the following piece of information. Let's go with the vertex is equal to, again, at the origin. This time I'm giving you the lattice rectum length is equal to 10. Okay, and it faces left. Let's see if I can make this properly here. Do I have a vertical line? Do I have a vertical line? Nope. Why can't I do that? Let me change the. This one. Will it do it now? Ah, there you go. Okay, the length of the lattice rectum is 10, and the parabola faces left. So if you were given that piece of information, again, quick Cartesian grid, boom, boom. If we know that it faces left and the vertex is there, so there's the, wow, what's going on? Okay, random color changes. There's my vertex, and I know that it faces left, which means it goes like this, and I know the lattice rectum is 10, which means my C value is 10 divided by 4, right? Because it's 4 C is your lattice rectum length. Then I know that C is equal to 2.5, which means 2.5 over, so 1, 2, 3, 4 at 2.5 is going to be my focal point. 2.5 right there is my focal point. And then a length of 10 means that here, up here, and down here is going to be a distance of 5 and 5, which means this is 5 up here. This is negative 5 up here. Okay, not very accurate, but if I do it on a grid, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so this is how we quickly sketch a parabola given the information that we are given. All right. Okay, so now let's continue with, let's look at, what if we had parabolas that did not start at 0, with no vertex at 0, 0. So now we're getting into parabolas with parameter h and k. Parabolas with parameters h and k. Okay, let's make that bigger because it's a title. 50. Expand it out with parameters h. No, h and k. H should be on the next line. Oops. Oops. Undo that. H and k. Okay, so that's our next quick little topic. So how does that change our equation? Well, we know that if we have a parameter with parabolas with h and k, what it means is that instead of having a curve that is centered, on 0, 0, we would have one out here, or over here, or down here. Okay, anything like that, as long as this point is not at the center, or okay, none of these points are here, then we have something with h and k. So how do we express that into the equation that we were given? So right now we have this, 4cy equals x squared. Technically we have 4 different ones. We have 4cy equals x squared. We also have negative 4cy equals x squared. And then we have 4cx equals y squared. And negative, oh, just use different color for this one, orange. Negative 4cx equals y squared. So why do we have four different types of equations? Well, if I go back, do I have an eraser? I will erase this stuff. Oh, I do. Look at that. Wow, it's so small. Why is the eraser so small? Uh, so the four types are, that's a quick erasing and it's a terrible erasing, but we'll deal with it. We'll live with it. 1, 2. Okay, if we have 4cy equals x squared, basically what we have is a, stop doing that. Basically what we have is this one. The red one looks like this. Boom. I believe we wrote this down last class as well. Okay, and the green one, negative, means it's upside down. The blue one, 4cx equals y squared, is a positive in the horizontal distance, and then the orange one is a negative going the other way. They all have their vertices on the 0, 0, the origin. So how do we adjust these if our vertices are not on the 0, 0? Well, we plug in h and k, and we know that h always goes with the x and k always goes with the y, right? So the only difference is they become this. 4cy minus k is equal to x minus h squared. That's for the first one. And then the second one just becomes negative 4cy minus k equals x minus h squared. That's the second one. Okay? And then the third and fourth one, well, the h comes on this side and k goes on the other side. I should probably use the same color I used up top. Oh well, forgot. So 4c, and this time x minus h equals y minus k all squared. And then the orange or burnt amber one looks like this. 4c x minus h equals y minus k squared. Okay, so that is just the, I guess, generic or, yeah, generic equations with no numbers in for c and no numbers in for h and no numbers in for k. But everything else applies. Okay, so as soon as we have a parabola that is not centered on 0, 0, the origin, we have to start applying these four equations down here. And let's continue. I feel like continuing. So general and standard forms. This is pretty straightforward. This is exactly the same as what we did for all the other conics, from ellipses to circles to hyperbolas. It's the exact same thing here. For our standard form is what you see up here. These four are our standard form. Okay, so do I have a highlighter? I just use light green, light yellow, sorry. These four are our standard form. Okay, so what is our general form? Our general form would be the other one that we know oh so well. It is going to be in the form of ax squared plus by squared plus cx plus dy plus e is equal to 0. Okay, again, don't get the c confused with the focal length. It is not the focal length. It is just another number, right? So capital A, capital B, capital C, capital D, capital E. And that's just a number, right? So to convert from one form to the other, we know how to do it, but we're going to do it again anyways. So example 1, let's convert from a standard form to a general form. Example 1. Let's start with 8y minus 4 is equal to x plus 2 squared. Okay, so this is in the form of that one right there. So 8 is 4c, therefore you know c right away is 2. Does that help us? Not really, not when we're converting forms. If we want to graph it, yes, it does help us. But when we're converting forms, it doesn't really make that much of a difference. So how do we convert this form to a general form? We expand it out. We expand out the brackets. Get rid of the brackets and then move everything to the left side and you have that. So we have 8y minus 32 is equal to x squared plus 4x plus 4, and then move everything over to the other side, and we end up with um, negative x squared plus 4x plus 8y minus 36 equal to 0. There you go. That is the standard form equation converted to general form. Not too difficult, it's just expanding out the brackets. So let's do one going the other way. Do one going the other way quickly, and then I can send you off to do some work. So now let's go backwards from general form to standard form. So if we have y squared plus 6x minus 4y minus 20 equals 0, we should go. Now, the observer ones will notice that even though I gave you ax squared plus by squared plus cx plus dy, when you are doing it, you're only going to end up with one variable that is squared. Okay? It's one or the other. You're not going to both of them. So if we were doing this, how do we do it? Well, we did what we did with the other conics. We complete the square. So let's keep these on this side and move the other stuff to the other side. So now we can complete the square here. So yx minus 4y plus 4 should complete it. And that leaves 6x plus 20 plus 4 as well. Right? Add. So that means this one is y plus, oh no, minus, sorry. Y minus 2 squared is equal to negative 6x plus 24. Factor that out as well. So you take out a negative 6 and you get x minus 4 on that side, and then y 2 squared. Okay? And then now we've converted from standard to general, and then from general to standard. Okay, so to quickly go over everything, we started out with, again, trying to prove that that formula actually does equal a parabola because we use something from Desmos, work backwards using this little equidistant shape thing, same length, same gap, okay? Or the light reflection, find a focal point. And then the next thing we did was we went into graphing it. If you are given certain points, you are able to graph it because you plot the vertex, plot the focal point, plot the gap in your two lattice rectum points, and then sketch out the graph. And then we added the h and k parameters for anything that is not centered on 0, 0. And we have 4 different standard equations. And then lastly, we converted between this general and the standard form. Okie dokie. Now we can go do the work that's also on the webpage.